So let's see another example. Here is a matrix that is A. It is a 2 by 2 matrix. And this is also a square matrix, right? Because the row and column, the value of row and column, the two are same. So that's why this is a square matrix. And also this is a square, this is also a, I mean, okay. This is a square matrix, okay? So now we have to convert this matrix as inverse matrix. So that's why we have to write down the corresponding identity matrix on the right side. So we have to write down a 2 by 2 identity matrix on the right side. So you see here, I have written here. Identity matrix means their main diagonal, the entries of main diagonal, it will be 1, and all the values of other entries, they will be 0. Okay. So I have written down the corresponding identity matrix here, and now we have to convert this this matrix into RREF form, okay? Or we have to convert this main matrix into some kind of identity matrix, okay? So that's why we can do just two simple operation. So you see here, we have 2 and we have 2 here, right? Okay. So our main diagonal is okay, right? This is 1. So we don't need to think about changing this this value. Now we just need to make this 2 and this 2. We have to make this 2. We have to make these 2 entries to 0, right? So to do this, we can multiply 2 with the first row. We can multiply 2 with the first row. So it will be 2. It will be 4. It will be 2, and it will be 0, right? And then we subtract the first row from the second row. Okay, here is the operation, and we substitute the value to the second row. So subtract the first row from the second row. So R2 minus 2 into R1, that means 2 minus 2, that is going to be 0. 1 minus 4, that is minus 3. 0 minus 2, that is minus 2, and 1 minus 0, that is 1, right? So we got our first we got this value as 0. Okay, and now we have to make our main diagonal as 1, right? We have to adjust our main diagonal. So we wanted all the entries of in the main diagonal as 1. That's why we can just divide the second row with minus 3. Okay, so you see, if I divide the second row using minus 3, so this minus 3, they get cancelled, and I again get 1, right? And 0 by minus 3, it will also make 0, and minus 2 by minus 3, that will make 2 by 3. Okay, you can later on just cancel this minus sign. Okay, here, and 1 by minus 3, that is minus 1 by 3. Okay, or you can just see here minus 1 by 3. So this was the second operation. And now let's go to the third line. So now we have to make this 2 as 0, right? So we can do what we can do. We can multiply 2 with the second row. That means 2 multiply 1 is 2. Sorry, this is 0. 2 multiply 0 is 0, and 2 multiply 1 is 2. Then here 2 multiply 2 is 4. That means 4 by 3. And then 2 multiply 1 is 2. That means 2 by 3. So I just multiply 2 with the second row. and then I subtract the second row from the first row. That means on minus 0, and I also put the value to the first row because I need this value as 0, right? So on minus 0, that is going to be 1. 2 minus 2, that is going to be 0. On minus 4 by 3, that is going to be minus 1 by 3, okay? On minus 4 by 3. So it will be 3, that means 3 minus 4, that is going to be minus 1 by 3, okay? Minus 1 by 3. So I write down here minus 1 by 3. And then 0 minus 2 by 3, that will be 2 by 3, okay? 0 minus minus 2 by 3, that will be 2 by 3. So we converted our main matrix into a identity matrix, right? So this matrix right here, this is our inverse matrix of A. Okay, guys. I hope this time you can understand more easily, right? Because this matrix is 2 by 2 matrix. This matrix is very easy to convert into some kind of identity matrix or RREF. So guys, can you understand right now how do we make inverse of a matrix?
Yes.
Okay. How about Hassan, Alamin, Zakira?
Yeah, bro. Got it.
Okay. I'm your friend, so why to close your mouth? You must speak. Okay.
I already did.
Oh, I have written triple R. No, this will be RREF. RREF. I need a new mouse, I think, because this mouse isn't so good. Anyways, so we can just move forward to the next lecture, I think. So this is just theory, okay? You don't need to remember all this theory because this theory are little complex to understand, okay? But the thing is same, okay? You just need to learn how we calculate. Okay, about homework, I am doing it, okay? I'm doing it. So I haven't completed because I am from AI major. So we have extra advanced math, and that math is so much difficult, okay? I had a group study just before 3 hours ago with Reda and Yunus. So we had around 2 hours group study. So after that, we could understand some parts over there. So I have a lot of homework to do. That's why I haven't finished. But I think tomorrow morning I will finish the linear algebra homework. I mean the test paper, okay? And I will give
Great.
the answers. I'll give the
Homework.
answers to all of you.
Did you record that practice first, homework?
Yes, I have recorded this. I
missed it, bro.
Zero
Because I
matrix.
put on YouTube.
Yeah, I have
I'll
recorded
check it out.
this. Yeah, it's okay. Trivial solution, geometry.
Thanks, bro.
Yeah. So let's continue to the next lecture. That is gonna be lecture 7. And let's see what we can learn. So the next lecture allows you also discussed about the inverse matrix. So the same thing, okay? The same thing. So this one, it is called the first leading one, okay? Let me change the color. I think this color, no, this color is not beautiful. I don't know this color. Maybe blue. Yeah, this one, okay. So this entry, it is called the first leading entry, okay? Just a name, nothing else, just a fancy name of this pivot point. So the same thing here, you don't need to understand this part. But okay, so this is the main diagonal, you see, and this is the secondary diagonal. Okay, for only 2 by 2 matrix, if AD minus BC not equal to 0, then we can find the inverse matrix this way. Okay, so there is a shortcut for 2 by 2 matrix. Okay, like if AD minus BC is not equal to 0, then using this formula you can find the inverse matrix, but maybe only for 2 by 2 matrix, so a small formula. Okay, anyways, we can continue. Okay. Finding the solution of a linear system, A must be a square matrix, A need to be invertible, A into X equal B. This linear system have only one solution if A is invertible. Okay, so deadline is 22. Okay, fine. So our homework is this one, right? That one Zakira was talking about, this one. Chapter 2, Determinants, non-singular. Okay, so now we are going to learn determinants. Okay, determinants means det A. Okay, let me just reopen this because it is making some problem. Okay, just let me. Lecture 7. So now we will learn determinant. So the result of a determinant is a real number, just a number. Okay, and to find determinants, it must be a square matrix. And then, okay, and then if the determinant is equal 0, then it is singular matrix. And if the determinant is not equal to 0, then it is a non-singular matrix. Okay, so if A is a n by n matrix, that means a square matrix, the determinant of A denoted as, that means we can write down it as det A. Okay, or determinant of A, or this kind of absolute value sign. Okay, or modulus A is a number that we associate with a matrix A. Okay, so you can write down the determinant as this two form. Okay, det A or absolute value of A. I mean the modulus A. Okay, guys. So let's see how can we find the determinant. So see here, previously we calculated, we saw a small formula, like how can we find the inverse matrix of 2 by 2 matrix, right? Let me show you here. This formula. Okay, for only 2 by 2 matrix, we could find the solution using this formula. So here, this AD minus BC, this was our determinant. Okay, so if you look at here, this AD minus BC, it was our determinant, and we can write down it this way, either det A or modulus A. Okay, or absolute value of A. And if it is not a 2 by 2 matrix, or if it is more than 2 by 2 matrix, then we have to write down this way, like A11, A12, A13, and then again A11, and then again A12. Okay, and all the entries below here, they will be same here. Okay, all the entries below here, they will be same here. Okay, you see. Oh no, sorry, not this way, not this way. The first So A1 1 2 1 3 1. Okay, so you see, like we have some kind of angle. We have to write down this way. Okay, so firstly, this part is just a matrix. Okay, nothing more. This part is just a matrix. So here is something more, that is A11, then A21 and 31. A12, oh yeah, right. So yeah, so this part is a matrix. Okay, and this extra part, this is nothing but this two column. Okay, you just need to write down this two column again here. Okay guys, and then you need to multiply this way. Okay, this way. So I have marked them here. So if you multiply this way, A11 into A22 into A33, okay, plus A on 2, A23, A31, okay, A on 2, 2, 3, 3, 1, then plus A on 3, A21, A33, okay. And when you do the process, reverse process, so you have to do this way, like A31, A22 and multiply A31, A31, right? A13, A22, A31, then minus A11, A23, A32, then minus A12, A21, A33, okay? So the first step will be from left to right, okay? You multiply this way and there will be plus, okay? And when you come from right to left, it will be minus, okay? It will be minus. So this way, if you just calculate this way, you can find the determinant. So let me show you some real example. So here is a matrix. Here is a 3 by 3 matrix. Thickness. Okay. So here is a 3 by 3 matrix, right? So we just need to write down this matrix here, and then our first and second column. Then we have to take our first and second column. We have to copy our first and second column here, okay? And now, and before copying that, we need to draw a horizontal line, okay? So we need to draw a vertical line before copying before copying this first and second column. Okay, guys. And now we need to do the multiplication like this way, okay? So 2 multiply 1 multiply 6 plus 5 multiply 2 multiply 5 plus 4 multiply 3 multiply 4 this way, and then minus, because we are doing the opposite, like the right to left operation. So 4 1 5, so 2 multiply 2 multiply 4, and then 5 multiply 3 multiply 6. So instead of taking minus with all of them, we could take a minus as common, okay? We could factor out this minus. We can factor out this minus. So the sign inside will be plus, okay? The same thing before, or you could just write down minus here and also minus here, okay? Then you will need to remove this bracket, okay? You will need to remove this bracket. Then also minus here. So the same thing as before. Here we just take minus out, okay? That's why all the sign inside this equation it becomes plus. Okay, so 2 multiply 1 multiply 6, that is 12. 10 that means 15 50. 12 multiply 4, that is 48, and then 4 multiply 5 is 20. So we just do the calculation, nothing else, okay? So the answer is minus 16. So this way we find determinants, okay? Or we can just tell DET, determinant of A. Or we can also express this way, absolute value of A, okay? Or this is modulus A. So this way we find the determinant of A matrix. Okay, guys? Do you understand? Hello?
Yeah.
Okay. So now let's see another. Okay. So now let's see another process. Okay. There is another way. So let me show you the formula. Mosquito biting me. So this is the formula. Yeah. So look here. We have some matrix here. So the same way we write down the same way. Okay. We just copy the first and second column. We just copy the first 2 column on the right side here, okay? And then, okay, no, sorry. This was the previous way. So the new way is, let me show you an example here. So this is another matrix, another 3 by 3 matrix. And here, firstly, let's calculate the first row and let's calculate for the first row and for the first column. So if we take the first row and the first column, then our first row and first column, we will omit this, okay? We will keep it out of our consideration. So we get this this minor matrix, okay? So now we have to write down this minor matrix here. 3 minus 3 and 5 1. And now you just multiply this way. From left to right, that means 3 multiply 1, and then from you could say right to left, okay? That means from up to down, and then down to up, okay? This way. So 3 multiply 1 minus 3 multiply 5. So my sign could be this way, like from left to right and then right to left, okay? Or it's up to you how you memorize. So the answer is 18, right? 3 multiply 1 is 3, and minus 3, then plus 3 multiply 5 is 15. So 15 plus 3 is 18, okay? So this is determinant of minor matrix M11, okay? And now let's see M23, okay? M23 means column 2 and row 3. Sorry, row 2 and column 3, okay? Row 2 and column 3. That means this one. So when we calculate this one, we have to omit the column of this this entry and also the row of this entry, okay? Because we are considering 3. So now we are left with 1 minus 1 and 4 5, right? 4 and 5. So that's why we write down 1 minus 1 and 4 and 5. So now if you multiply the same way, like 5 multiply 1, that is 5, and minus 1 multiply 4, that is minus 4. So it will become plus 4. So plus 4 plus 5, that is 9. And then let's find a determinant of the minor matrix M32. That means column number 3 and row number 2. So column number 3 is, the third column is 1 2 3. Sorry, I forgot. Sorry. So this one is row, right? Row number 3 and column number 2. So this is our third row, and column number 2 is here, okay? So our point is here, our entry is here, right? So this entry is in the position of third row and second column, okay? That's why we write down this way, M32. So now we will omit this column and this row, okay? Because our entry is here, right? So now we are left with 1 2 and 2 minus 3. So that's why I write down here 1 2 and 2 minus 3. So if I now multiply, so minus 3 1 and multiply 1, that is going to be minus 3, and minus, this minus is the minus of formula, okay? So minus 2 multiply 2, that means 4. So minus 3 minus 4, that will be minus 7. Okay, guys? So this way, A11. Now we got our 3 minor matrix, right? So now we have to find out, like the values, okay? Which values I have to write down here. So okay, let me use this. 1 minus 1 2. 1 minus 1 2. Okay. So I hope you know how to calculate this part, right? I have already discussed here. So we got 18, we got 9, and we got minus 7. So here is 18. Then where is 9? Okay, let me show you here. So we are going to compute the determinant of A. Okay, here is our A matrix. So for the first row, row and first column, I mean this entry. So this is called A11, okay? And the value of A11 is 1. So we write down this way, like minus 1 to the power the value of column plus the value of row. That means this entry here our row is 1 and our column is 1. So we add this two, we add this two value, okay? So minus 1 to the power 1 plus 1. And then when we are considering this entry, then we will cancel out or we will omit the corresponding column and corresponding row, okay? So we are left with 3 minus 3 and 5 and 1, right? So that's why I write down here 3 minus 3, 5 and 1. So 3 multiply 1 is 3, minus 3 multiply 5 is minus 15. That means 3 plus 15, that is 18, okay? So this way A on 2, it will be, A on 2 means where? row number 1 and column number 2, right? A12, it means row number 1, that means here, and column number 2. Okay, row number 1 is here, and column number 2 is here, right? So this entry, okay, this entry is on the first row and on the first column, okay, on the second column, sorry. So this entry here, this is our A12. Now we have to calculate the value. So we write down this way, like minus 1 to the power 1 plus 2. That means minus 1 to the power the value of row plus value of column into determinant of submatrix M12. So for this entry, we can omit this column and this row. So we are left with 2, 2, 4, minus 3, minus 3, 1. So I write down here 2, 4, minus 3, 1. So now I do this operation, like I multiply this two number. So 2 multiply 1 is 2, and then 4 multiply 3 is, then minus this minus is for the minus for formula, and 4 minus 3, that is minus 12. So minus 12, it was 2, then minus, okay, and there was another minus on the left side. So ultimately this is gonna be 2 plus 12, that means 14. So 14 multiply minus, that means minus 14. Okay. So I hope you can calculate this part and also this part, okay? Because I have already calculated on here, right? So the same way you can calculate all the three value here, and then you have to add them out, okay? You have to add them, like this is 18, this is 14, and this is 4. So you have to just add them, okay? So you will get 28. Thanks for your help, okay? Okay, I'm here, don't worry. Okay, so at the end, we just need to add this value, that is 18 plus minus 14 and plus minus 2, okay? So 18 plus minus 14 and then plus minus 2, okay? It is gonna be minus 16, that means minus 16. Oh, okay. Okay, this was minus 1 to the power, okay, that means A11 into a capital letter 11, okay, fine. Okay, so you see here this value. So before adding them, so this is the formula, okay? The determinant of A will be a small letter A11 plus capital letter A11 plus a small letter A12 into capital letter A12. So we already calculated all this value, right? So now we just need to substitute the value back here, okay? From here. So expand along the first, okay? So how do we get this a small 1, 1, a small 1, 2, right? So if you have a close look here, when we took this this entry, so this was our small 1, 1, okay? And after then we took this entry, right? So this was our a small 1, 2, and then we took this entry, right? So this was our a small A13. So this way we got our a small a value and our capital A value, okay? So we multiply them and finally we add them. So then we get the det A, or the determinant value of A. So I think the first way is much easier, right? I think this way is much easier than calculating this way, okay? So I think you can follow this way, okay? No need to follow this way. But still,
Okay.
our teachers discussed in the class. That's why I also discussed with you guys. So now we have lecture date AT. You see here it's 12:13 a.m. in my country. So I feel pretty much sleepy right now. Solution
Oh,
number
it's
2.
late.
But I will
I'll
finish.
watch the motivation and then continue.
Oh, wait. Single row or column. So I think nothing else for. Okay, so there was something more like our Laushi calculated what? Change the sign. If we interchange two rows, okay, there was some kind of formula, little formula that you need to know. Okay, let me discuss them. Single note, single row column operation. So down here we have some elementary operation, like for a small formula. Okay, determinant of A T is equal det A. Okay, determinant of A. Determinant of B is equal minus determinant of A. K to the power n determinant of K is a constant. Single row or column. A single row or column is different, but all other entries are same. So R3 minus K into R1. So it was like the same as we talked before, like when we try to make when we try to calculate some matrix, or when we try to find the solution of a matrix, or when we try to make some matrix to RREF. Okay, so then this is our formula. Okay, so I am giving you some real example. I think that will be much more easier for you. So if we have some kind of replace IJ, okay. If determinant of A is not equal to 0, then A is non-singular. If equal 0, then singular. Okay, so determinant of A into B is equal A into B. Okay, then determinant of A inverse is on by determinant of A. So you see here we have some small formula, like if determinant of a matrix A is not equal to 0, then A is non-singular matrix. And if determinant of A is 0, then A is singular matrix. And determinant of A multiply B, it will be determinant of A into determinant of B. Okay, and if the n by n, that means a square matrix A is non-singular, that means determinant of A is not equal to 0, and then determinant of A inverse, it will be on by determinant of A. Okay, you see here A inverse, it will be on by determinant of A.